All right, hello everybody. Today we are going to talk about solving quadratic equations using three methods. Number one, completing the square. Number two, the quadratic formula. Number three, factorization. Okay, so let's start with completing the square. So our first method, completing the square, it kind of involves imagining that there's a square hidden inside of this. This is not a perfect square quadratic equation, but we're going to imagine that there's one hiding inside of it, and then we're going to add or subtract something to the end of that to make it into essentially a perfect square and then some. And the way that we do this is we look at our second part of our trinomial expression. So let me draw something right here. We have ax squared plus bx plus c equals, let's say, y. So we have a is the, basically we have a that goes with the x squared, b that goes with the x, and c is our constant. These are our coefficients of the x squared and the x. So a is the first coefficient, b is the second coefficient, and c is the constant. So we will apply this to our equation, our first equation here. We have x squared plus 6x minus 5. So that is not a perfect square, but what we will do is we will take half of our middle coefficient. So half of our b coefficient. You know what? Here, I'll move the camera here while we do this problem. Okay. So we will take half of 6, as we know is 3, and I will set it up x plus 3 squared. So this is not the final answer, because as we know, when we do x plus 3 squared, if I were to re-expand that out, here's what I would get. If we do the FOIL, first, outer, inner, last, we will have x times x is x squared plus 3x plus 3x plus 9. So we will have x squared plus 6x plus 9. So if I combine the two, 3x plus 3x, we have x squared plus 6x plus 9. That's what this is equal to. However, I don't have a 9 at the end of this. I have a negative 5. I have a minus 5. So what I have to do is I have to add something at the end of this to make a positive 9 become negative 5. So what I will do is I will subtract 14 from the end of this, knowing that this will turn into this. So this minus 14 will go here. Okay, that might be a bit confusing. Basically, you'll take half of 6x is 3. So you have x plus 3. Now you will re-expand that, x squared plus 6x plus 9. Then you see, what do I need to add or subtract from the end of this to make it become our original equation? So in this case, since we have a positive 9 that goes with our square number, but we want a negative 5, we have to subtract 14. So we have, this is our correct complete the square equation. Now what we have to do is use this to solve for our values of x that make this statement true. So what I'm going to do is I'm going to throw this 14 to the other side by adding 14 to both sides. So I want the square by itself, and then I want the 14 on the other side. So what I'm left with is x plus 3 squared is equal to 14. There we go. X plus 3 squared is equal to 14. Now, since I have the whole parenthesis here being squared, I can take the square root of both sides, and I have x plus 3 on this side, and I'll have the square root of 14 on that side. So I'm going to take the square root of both sides. Square root, square root. So what I'm left with is the square root of 14. Now here, I'll drop it down. Square root of 14 is equal to x plus 3. Now remember, my goal is to get x by itself. So how I can get x by itself is subtract 3 from both sides. So I have x is equal to square root of 14 minus 3. But here's the catch. The square root of 14 has a positive answer and a negative answer. So let's do some math over in this free space over here, and it'll tell us our answer. So I have x equals, I'm going to say the positive square root of 14 minus 3, and x equals the negative square root of 14 minus 3. So we can use our calculator because we don't know the square root of 14 off the top of our heads. So I will take the, let's see if this is showing up. I'll take the square root of 14 minus 3. So our value is 0.74, let's round it to 3 decimal places, 0.742 equals 0.742. Now our other value, we want to have the negative square root of 14 minus 3. And that will give us negative 6.742. Okay. So, let's double check that. I like to use Desmos. I think Desmos is great. Let's use Desmos. To try to, let's see here. If I were better at editing videos, I would do this separately. But I'm not very good at editing videos. So this is what we get. So Desmos, let's put in our equation. We have x squared plus 6x minus 5, and we're going to say that's equal to y. So we're going to look at the places where y is equal to 0. So these two values, if you get really close, you can see we have negative 6.742 and positive 0.742. So these are our numbers that we have here, and those are the values of x when y is equal to 0. So if I were to change this, one thing real quick, if I were to change this so it's not equal to y but rather equal to 0, it will just give us straight lines, vertical lines at these same locations. So it will give us the same answer whether we put in equals to 0 or equals to y. But if we put it equal to y, then we see that the actual graph is a parabola. And that's what our quadratic equations create. So that is how we solve by completing the square. Next, we're going to solve an equation using the quadratic formula. So the quadratic formula is simply something that we memorize. Let's see, I'll move this over again. I'll make it squared off. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. It's worth memorizing because I've always found that this is the most reliable method of solving lots of quadratic equations in my life. There are lots of unusual situations where this comes in very handy. So I've considered it worthwhile to memorize negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's worth memorizing. And what that means, the a, b, and c, goes back to our thing here where a is the coefficient of x squared, b is the coefficient of x, and c is our constant. So if I have this equation, let's say it's x squared plus 7x plus 12 equals 0, I'm going to plug in 1. There's an invisible 1. If it doesn't show you anything in front of the x squared, then our coefficient is just 1. It's an invisible 1. And then 7 is b, and c is 12. So we will just plug in those numbers. We have negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 12 all over 2 times a, 2 times 1. Okay, so let me erase our work over here. And let's do this over here. So we've got negative 7 plus or minus the square root of 7 squared, so we're going to turn that into 49. 49 minus 4 times 1 times 12. So 4 times 1 times 12 is going to be 48. Well, that makes it very easy. All over 2 times 1. So I'm just, as I go across, I'm just doing the multiplication. So, the next step we do is we subtract 49 minus 48. Well, we know that that's 1. That's very easy. And we know that the square root of 1 is 1. So our next step is going to be super simple. We already know that this is 1. We know that the square root of 1 is 1. So we can kind of fast forward on the next 2 steps. So we have negative 7 plus or minus the square root of 1 over 2. So let's turn that into 2 separate equations, one for the plus and one for the minus. So when it says plus or minus, that means you're going to have 2 answers. So here I will do the plus, and let's do the negative 7 minus negative 1 over 2. So I've basically split it where it originally says plus or minus. Here's our plus, here's our minus. You have to split it and do 2 separate solutions. So negative 7 plus the square root of 1 will be negative 6 over 2, which is equal to negative 3. And this one we have negative 7 minus the square root of 1 will be negative 8 over 2. So we have negative 4. Let's see if that is what we have. So once again, I will use Desmos. Ooh, come on. Okay. All right, so I'll use Desmos. I will put in the equation that we use. So we have x squared plus 7x plus 12. Alrighty. So we are looking for the values where y is equal to 0. And if we zoom in, we can see the parabola. And if I go here, I can see that there is the point -3, and there is the point at -4. So we have found the correct answers, -4 and -3. Now remember, if we switch this from y to 0, then it just gives us two vertical lines, again at -4 and at -3. So that is how we solve our quadratic equations using the quadratic formula. Now let's use our final stage of factorization. So the way that we're going to do this is we are first going to multiply our A value with our C value. So we will multiply the first and the last part, the A and the C. So 3 times 8 is going to be 24. Now we're going to take all the possible factors of 24. So we've got 24 times 1, 2 times 12, 3 times 8, 4 times 6, and then we'll double it because they could also be negative. So it could be -24, -1, -12, -2, but we're going to leave it here. Okay, so what we need to ask ourselves is, which one of these sets will add together to be our middle number? So we want to add 2 of these together to make it become 14. Well, 6 plus 4 is 10. 8 plus 3 is 12. No, it's 11. Sorry, I knew that. 12 plus 2 is 14, which is what we're looking for. It's the 12 and the 2. So, we know that once we factor it, there will be a 12 and a 2 that will add together to be the 14. And that gives us our hint that when we try to factor, we're trying to make our 12 and 2. So 12 and 2. So what that means is I'm going to create 2 brackets. I'm going to put 3x here, I'm going to put x here, and now I have to somehow make 12 and 2 using this x and this 3x. Well, the 3 can't multiply by anything to become 2, but the 3 can multiply by a number to become 12. So I'm going to put this 3 will have to multiply with a 4 over here. And this is positive, this looks like it's going to be positive. So we've got the 3x with this 4 will be this 12x. And then what we need left over is 2. So let's see if we did this correct. Let's re-expand this to see if it becomes our starting point. So this 12, no, here, I'll re-expand it and it'll make sense. So let's do our FOIL method. First, outer, inner, last. We've got our firsts, our outers, our inners, and our lasts. So we're going to multiply 3x times x, 3x squared. Now next we're doing our outers. So we have 3x times 4. is 12x. Now we will do our inners. We have positive 2 and x, 2x. And then we will do our lasts. We have positive 2 times positive 4 is 8. So let's add together our 12x and 2x. We have 3x squared plus 14x plus 8. Awesome. This tells us we have the correct factors here. So we can use this now. If these are equal to 0, then what that means is I have to make this bracket become 0, or I have to make this bracket become 0. That's how we multiply to become 0. One of our factors has to be 0 in order to multiply to become 0. So what value of x in our right bracket would make this whole bracket become 0? Well, since we have a positive 4, the opposite of that will be negative 4. So if we have a negative 4 for x, then we know that this whole bracket becomes 0 and our equation becomes true. So we have x equals negative 4. This is one of our correct solutions. Now our other correct solution, we look at the other bracket. So we want to make this become 0. We want 3x plus 2 to equal 0. And we will just solve it like it's a normal algebraic expression here. So we will have, let's subtract 2 from both sides. Remember, we're trying to get x by itself. Subtract 2, subtract 2. So we have 3x equals negative 2. Now let's divide both sides by 3. Divide by 3, divide by 3. So we will be given x equals negative 2 divided by 3. Negative 2/3. So let's check using Desmos to see if our two answers here are correct. Okay, so I'm looking for 3x squared plus 14x plus 8, and let's say it's equal to y. Okay, so I see that the point of negative 4, 0 is correct, so that's where the parabola is crossing the x-axis, and we have negative 0.667, which is negative 2/3. So if we set this equal to 0, you can visualize it a bit easier. Negative 4 and negative 2/3. All right, so we have done it correctly. We have our answers, and hopefully you have learned how to solve quadratic equations using these three methods. All right, have a great day. You guys are wonderful.